Look at this Morpho butterfly. That electric, glowing, unreal blue on its wings, the kind of blue that almost amazing to look at. Now here's the mind-blowing part. There is no blue on that butterfly. Not a drop. Not a molecule. If you grind up its wings and analyze them under a microscope, you will not find a single speck of blue pigment. The same is true of peacock feathers. The same is true of a hummingbird's throat. Some of the most vivid blues in nature don't actually exist. Welcome to Science Curiosity. Today we're diving into one of the strangest illusions in all of biology: structural color. The trick of physics that lets living creatures create colors without ever making the pigment. Here's the setup you need to understand. Almost every color you see in nature comes from pigments, chemicals that absorb certain wavelengths of light and reflect others. Chlorophyll makes leaves green. Melanin makes hair brown. Carotenoids make salmon orange. That's pigmentary color. Chemistry, but there's another way to make color. A way that uses no chemicals at all. A way that manipulates light itself, bending it, splitting it, canceling parts of it out until the wavelength you want is the only one left glowing. That's structural color. And it's the reason the Morpho butterfly looks the way it does. A Morpho butterfly's wing is covered in thousands of tiny scales. Each scale is only about the width of a human hair. And when scientists put those scales under an electron microscope, they saw something that looked like it came out of a science fiction film. Every single scale is covered in microscopic ridges, tiny structures shaped like miniature Christmas trees. Each tree has 10 to 13 layers of cuticle. The same material insect exoskeletons are made of stacked one on top of the other, separated by thin layers of air. Each layer is only about 60 to 90 nanometers thick. For scale, that's about 1,000 times thinner than a human hair. And that's where the magic happens. When white sunlight hits those layered nanostructures, something incredible happens. The light waves bounce off every single layer, the top of the cuticle, the bottom, the air gap, the next layer, and so on. Now here's the key. Light behaves like a wave. And when waves overlap, they can either reinforce each other, this is called constructive interference, or cancel each other out, destructive interference. The Morpho's wing is precisely engineered so that only one wavelength of light gets constructively reinforced. Blue light. Every other wavelength, the reds, the greens, the yellows, gets canceled out. So even though white light hits the wing, only blue light bounces back into your eyes. The butterfly isn't blue. The butterfly is a filter that only lets blue survive. Here's where it gets even wilder. Because the color comes from structure, not pigment, it does something no dye can ever do. It shifts as you move. Tilt the wing slightly, and the blue shimmers, deepens, or vanishes altogether. That's called iridescence. It happens because the angle you're viewing the wing at changes the exact path light takes through those nanostructures, which changes what gets reinforced and what gets canceled. A painted wall can never do that. A dyed shirt can never do that. Only structure can. And there's a hidden twist. Underneath the transparent cuticle layers, the Morpho actually does have a dark pigment melanin. But its job isn't to make the wing blue. Its job is to absorb any stray white light that would otherwise wash out the color. The melanin is the black paper behind the mirror. It makes the blue look impossibly vivid. The Morpho is famous, but it's far from alone. Look at a peacock feather. That shimmering electric blue and green? Structural color. The feather has microscopic barbules arranged in precise layered patterns, and they bend light exactly the same way. Look at a hummingbird's throat, that flash of ruby, or emerald, or violet structural color. Look at the shell of a beetle, glinting like polished metal structural color. Look at the shimmering inside of a seashell structural color. Nature figured out this trick hundreds of millions of years ago. Long before humans invented paint, evolution had already invented something better: color that doesn't fade, doesn't wash out, and never needs a single chemical to exist. Scientists have been trying to reverse engineer this trick for decades, and it's opened up an entire field called biomimicry. Engineers are now designing paints that never fade because they use nanostructures instead of pigments. They're developing anti-counterfeit inks for currency that shift color like a Morpho wing. They're prototyping structurally colored fabrics that never need dye, cutting out one of the most polluting industries on Earth. There's even research into structurally colored displays that could replace LED screens that work using pure light manipulation instead of energy-hungry pixels. All of it inspired by a butterfly that has been quietly wearing physics on its wings for 50 million years. So the next time you see that impossible flash of blue on a butterfly, a peacock, a hummingbird's throat, remember what you're really looking at. You're not seeing color, you're seeing architecture. You're seeing light being shaped by nanostructures so precise, so ancient, and so beautifully engineered that human science is still trying to copy them. The Morpho butterfly doesn't wear blue. The Morpho builds blue 1 nanometer at a time. If this rewired your brain, subscribe to Science Curiosity. We're diving into another impossible thing nature quietly does every single day.